And we're in 2.3. We are adding and subtracting radical expressions. Now, this is really going back to the same way that we added and subtracted regular polynomial expressions. Same rules are going to apply, or very similar rules. So let's look at our polynomials right here. 2x minus 3y plus 4, blah, 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 blah. Those are polynomials. Add them. Collect your like terms. If we're going to be adding them, we add the coefficients of the like terms. If we're subtracting, we subtract the coefficients. So let's look at them. We've got, let's take the brackets out first. 2x minus 3y plus 4 minus 3x plus y minus 3. And we're going to collect all of our like terms. So I'll color coordinate for you. There's my x's, those ones go together. There's my y's, those ones will go together. There's my constants, those ones will go together. That's going to give us 2x minus 3x, negative x. Negative 3y plus y, that's negative 2y. 4 and negative 1, that's plus 1. Done deal. Let's go to the next one. Ooh, this one's got a negative happening in between. That's a little bit of a problem that we got to always be wary of. Bring that negative in. Don't forget to do that. Okay, so let's take our brackets out. Negative 4x plus 5y plus 2 plus 2x now minus 3y plus 1. That's where the mistakes get made, is forgetting to bring those in and getting the wrong side. Collect our like terms again, just like we did. X's go together, y's go together, constants go together. We now come up with negative 2x plus 2y plus 3. Done. Just like the last one, we got to distribute in first. We're going to distribute the 2 into these set and distribute that negative 3 into those 3. So we get 2x plus 4y minus 4 minus 3x plus 3y minus 3. Collect all of our like terms. Again, color coordinating for you. X's together, y's together, and constants together. We get left with negative x plus 7y minus 7. Our radical rules are really going to be a combination between our polynomial rules as well as fraction rules. You can think of it kind of both the same way. We can simplify a lot of times our radicals. So if we're adding or subtracting, just like our x's and y's, we can only add like terms. We can only add terms with an x. Same thing here. We can only add terms with the same radicand. We can't bring in the radical 7 in with it. So these two will add together, but we get left with that one by itself. So the first one here, I've got 9 of the root 5s. I'm going to take away 5 of those root 5s. Well, that's going to leave me with 4 of the root 5s. Just subtracting that coefficient. Next one, oh, I don't have anything that's like radicands. But wait, we can simplify them first. So that's what we ought to do. We got to simplify all these. So simplifying a cube root, either got to remember all your cube root, your perfect cubes, or just take it down to do your prime factoring. Divide by 2 gives me 12. Divide by 2 gives me 6. Divide by 2 gives me 3. Divide by 3 gives me 1. And I need groups of 3 like terms because it is a cube root. That's going to leave me with 2 cube root of 3. Again, color coordinating for you so you can see what goes where. Those, whoops. There we go, go on the outside. And the lonesome stays underneath. Then minus. Got to do the next one. All right, break it down. Take the 192. Divided by 2 gives us 96. Divided by 2 gives us 48. Divided by 2 gives us 24. Oh, we've got all those there. 24, 12, 2 and a 6, 2 and a 3, 3 and a 1. Groups of 3. There's a group of 3. There's a group of 3. I've got a 2 and another 2. 2 times 2, that's going to be 4. 4 cube root of lonesome underneath, the 3 stays. Then we got to do the same thing with 375. Let's take that up on the side. And break this one down. Let's start by dividing it by 5. Divide by 5, sure, gives me 75. Divides by 5 gives me 15. Divides by 5 gives me 3, 3, 1. And there's my group of... Whoop. That should have been a 5 there. There we go. Now we got the group of 3. Perfect. Comes out as minus 5 cube root of, again, that lonesome 3. Oh, look at that. We've got underneath there 3's all the same. We can bring them together. They're all like terms. So 2 minus 4 minus 5 gives us negative 7 cube root of 3. Done. Last one there. Oh, again, got to break all these up. These ones are perfect squares. So whichever method you do for reducing, I'm not going to show all those now. I'm just going to jump to the reduced form. That's going to reduce down to 3 root 7 plus 2 root 10 minus 3 root 10 minus 2 root 7. Now we look for what are like terms. Oh, we've got those ones are like terms. We also have those ones that are like terms. Let's bring them together. So then we've got 3 minus the 2 gives me just 1 root 7. And we've got the 2 minus the 3 gives me negative root 10. Can't go any further. Can't combine the 7 and the 10. Nope, nope. Now simplifying with variables underneath the radicand. Hey, it's going to be the same. We just have to remember to use what we learned in 2.2 to be able to reduce them and look for, maybe there's some absolute values sometimes. Maybe there's some restrictions that we got to watch out for. Right? So let's look at the first one. Oh, yeah. All of them have the same radicand. So they're like terms. Let's add them together. 6 plus 5, that's 11 minus 11. Oh, they canceled off. That gave us 0. But because we have a radical with a variable, we've got to make sure we're always looking at where are they defined. So the answer is 0, but this will only work if a is greater than or equal to 0. Our radicand has to be positive. All right, let's look at this next part, b. Oh, hey, the a squared b, that's in both of the radicands. That's the same. The only problem now is looking at, we've got the 50 and the 8. Got to change those to be the same in order to combine them. So let's reduce just the 50 and the 8 portion of it. Okay, the 50 reduces into 5 root 2 a squared b minus square root of 8. That goes down into 2 root 2. And then we've got the a squared b. Now, oh, hey, we've got the same underneath. Perfect. We can bring those together. 5 minus 2, that gives us 3 square root of 2a squared b. Now we've got to reduce the a squared b as far as we can go. The 2 stays. So we've got 3. We've got a square root of 2, that stays. A squared. The square root of a squared is a. But got to remember that that's going to be positive. A squared will always be a positive value. So we're always going to have a positive a. So let's throw that in. Absolute value of a. Then we got the b. Can't do anything with it. We're done. 3 absolute value of a multiplied by root 2b. Where is it defined? Do we have restrictions on the a? Okay. Well, a squared is always going to be a positive value. So a can be anything. A is an element of the real numbers. B, however, b could give us a negative underneath the square root sign. So b has to be greater than or equal to 0. Part C there, we're doing cube roots. Oh, Cube roots, there's never a problem with the restriction, so we know right off the bat, P is an element of the reals, Q is an element of the reals. Now let's start looking at going further. Hey, P cubed, Q is underneath. That's the same in both, but I got that 27. Got to deal with that. Let's first of all do cube root 27. Oh, that's a perfect cubed. That's 3 cube root P cubed Q plus 8 cube root P cubed Q. Woo! Now I've got common radicands. I can bring those together, add the coefficients, 3 plus the 8. That gives me 11 cube root P cubed Q. Now let's try to reduce what's underneath. I can reduce the P cubed. P cubed is equal to P times P times P. And I'm looking for a square root. That means groups of 2 to come out. Hey, I can do that. That's going to leave me with 11 P. Don't have to use the absolute value on this one because it's not a square root happening here. And then we're left with 1 P and 1 Q underneath. Oh, sorry, made a mistake there. That was a cube root, so I need a group of 3 there. Ooh, sorry about that. Sorry. Nobody was telling me there through the video. There we go. P comes out just as a P, cube root of Q. Done. And let's get into number 3 there. We got to simplify this. Notice what it says here on the end. It's telling us that n and m are greater than 0. As soon as it says that, we've got what the restriction is. We're told this, so we aren't going to have to use the absolute value signs because it's already telling us that they have to be positive. So if that's going to be the case, if it would be a question that we would need the absolute value in there, we're not going to have to use it because we're already told greater than 0. We've got like radicands, that one and that one, that one and that one. So let's just bring them together. So we got 7 minus the 3. That gives me 4 root m. 5 and the 2, those go together. 7 root n. Simplified. All right, again, we're told b has to be less than 0 this time because we got negative underneath each radical. And so we're saying, oh, it's got to be negative to make it a positive radicand. Okay, so we don't have to worry about that right now. Hey, they all have the same radicand. But wait, they're not all like terms. Cube root, square root, square root. Ooh, be careful, look for those things. Don't let them try to trick you up. So we can only combine the greens and the blues. So we get negative 7 cube root of negative 3b plus 11 square root of negative 3b. If you want, we can actually pull this negative out of the cube root one, not of the square root, but of the cube root. The cube root of a negative number is going to be negative. So we could take this one step further, if you would like to, and say 7 cube root of 3b plus 11 square root of negative 3b. Can't take the negative out of that one. Okay, a little bit trickier now. Ooh, we've got a and b are greater than 0. So we're told this again. That means we don't have to worry about absolute values on these ones. Nothing there has the exact same radicand, so we got to reduce them. Let's start with the 32a to the 5. Let's reduce that. I'm just going to take it over on the side. 32a to the 5. So let's start with the 32. Break down the 32. The 32 goes to the square root of 16. The square root of 2 chose 16 because it's the largest perfect square. So that's going to give me 4 root 2. But I've already got a 3 there. Don't forget that we had a 3 kicking it in front. Then we've got a to the 5. A to the 5 is really saying the square root of a times a times a times a times a. We're doing a square root, so I do groups of 2. That can come off, an a and another a. which is going to give me a squared. All right, let's bring this back together here, combine them. So we got the 3 times the 4, which is 12. A squared, all those are outside the house. And we've got a 2 and an a that have to stay inside. That's reduced now. Bring it up and over. 12, a squared, square root 2a. Doing the same thing with the 45b cubed. The 45, 9 and 5, so that's going to be 2 times the 3, square root of 9 is 3, root 5. B cubed, that's b times b times b. Group of 2, square root of b squared, that's a b. So again, I'll show you. Got a group of 2, b comes out. So, simplified, 2 times 3, 6. B, square root, 5b. Bring her back in. 6b, root 5b. We do the same thing with the 125. 125 breaks into 5 root 5. But I've already got a 5 sitting there, so I'm going to multiply those together. 25b. Can't do anything with the b that's underneath, so we get 5b. So again, square root of 125 is 5 root 5. Now, minus 2a, 72a cubed. Repeat the process. 72 comes down. We've got the square root of 72 being the square root of 36 and 2, so it's 6 root 2. But there's already a 2 kicking it in front, so the 6 times the 2 is 12. Then we deal with the a, and a, triple a, square root, group of 2, that's a root a. But there's already an a outside, so multiply those together, a squared, square root of 2a. Oh, nice, we got some common radicands. Let's bring them together. But also you now have to be careful that you have to make sure that when you're adding them, that the coefficients will add nicely together as well. They've got variables involved there. All right, yeah, those ones are gone. They're the same. We put it in, we take it out. We get left with negative 6b plus 25b. That's 19b and root 5b. Woo! That was fun. Finishing off here, discuss those ideas. What do we have there for information? Bring it together, solidify your thinking, and we'll see you in class.